In this lesson, we're going to be looking at how to graph something that looks like this particular equation. We're going to be graphing from what's called standard form. Now, right now, you don't have a way to graph it just by looking at the 6 and the 8. They don't tell us anything about it being shifted up, down, left, or right, not directly. But there are some things we can do in order to be able to figure it out. To start with, put this into your notes. You want to put down what standard form of a quadratic looks like, noting where A, B, and C are in that equation. And then this little equation here, very important equation on how to find the vertex, that x equals negative b over 2a. Having put that into your notes, we can now move forward and find the x-coordinate of the vertex from this standard form equation. So to find the x-coordinate of the vertex, we're going to use that little formula you just wrote down, x equals negative b over 2a. Now in this particular problem, we should probably identify what a, b, and c actually are then. So I'm going to start at the front here. A is whatever number is multiplied in front of the x squared. Well, there's nothing written there, which means it's got to be a 1. So a equals 1. All right, now for b. B is what's ever multiplied in front of the x term. So in this case, b is going to be negative 6. And then c, in case we end up needing it later, c ends up being 8. Now that we have those numbers, we can go ahead and plug it into this equation. So x equals negative. I'm just writing the negative in front of the fraction there. I'm not putting it into the fraction or doing any operations with it. All I'm doing is plugging in right now. That saves you a multitude of potential errors. Because the first thing we do on top is we plug in for b a negative 6. And then that's going to be 2 times 1 on the bottom. If you end up trying to cancel out that negative when you first plug in the negative 6, it can lead to errors because we can either forget to include the negative or we can include it twice. There's all sorts of things that can happen, so you're better off just to write it like this first. Having done that now, I'm going to go ahead and just leave the negative out front and now figure out what that fraction equals. So it's negative 6 over 2. And then negative 6 divided by 2 is a negative 3. And now I can deal with that negative that was sitting out front of the fraction. So x equals a negative negative 3, which is a positive 3. So we now know the x-coordinate of the vertex. It's at positive 3. We now need to find the y-coordinate of the vertex. Add this to the notes that you took down on standard form. We find y by plugging the value of x back into the equation. So now let's use that piece of information on finding the y-coordinate. And we're going to take our x value of 3 and we're going to plug it into the original equation for x. So we're going to go 3 squared minus 6 times 3 plus 8. And so y is going to equal 3 squared is 9, minus 6 times 3 is 18, plus 8. Go left to right when doing the addition and subtraction. So 9 minus 18 is a negative 9. And negative 9 plus 8 is a negative 1. So we now know the y-coordinate of our vertex is going to be at negative 1. We have the coordinates of our vertex then at 3, negative 1. That means we can now graph this equation. So on graph paper, you want to include this graph as well, so it's a reference for you. We're now going to graph this equation, which we know has a vertex at 3, negative 1. So the very first thing I'm going to do is go and plot that point at 3, negative 1. So that's right 3, down 1. Having done that, you now already know how to make the graph of this because you know what the parent function of y equals x squared looks like. It follows the exact same pattern because it has that x squared in it. So in order to graph it, we are going to go over 1 and up 1 on both sides. And then we're going to go over 2 and up 4 on both sides. And then we're going to go over 3 and up 9 on both sides. Remember that the reason why we do this is because it's an x squared equation. Whatever we go over, we square it to know how far to go up. And then in this case, we can't go up any more past the 9. If I went over 4, I'd have to go up 16. That doesn't fit on my grid, so I'm going to call that one done. Draw the curve that goes in through those points, and you've completed your graph. I'd now like you to practice this with this graph. So again, write this one down on your paper, do the entire work, make the graph, and then move on, and let's check and see what it looks like when we do it together. All right, so in order to do this one, we're going to need to graph it by first finding the vertex, which means I have to use x equals negative b over 2a. So when I plug in here, I'm going to go negative. B in this case is 2 over 2 times a. A here is 1 again. And so x equals a negative, that's going to be 2 divided by 2, which is 1. So I know my x-coordinate is negative 1. I'm now going to plug that back into the equation for x. So y equals negative 1 squared plus 2 times a negative 1 plus 1. So y equals negative 1 squared. Remember, a negative times a negative is always a positive. So negative 1 squared has to be a positive 1. Then plus 2 times a negative 1. That's a negative 2. So I'm just going to write that as minus 2. If you like to write it as plus a negative 2, that's perfectly fine. I just try not to have too many plus, minus, and things like that right next to each other because it can create some chaos if we let it happen too often. Then the plus 1 from the original equation is still just hanging on the end. So now y equals 1 minus 2 is a negative 1, and then negative 1 plus 1 is 0. So our y-coordinate here happens to be 0. So the coordinates of our vertex now, the all-important point that we get along the way here, is going to be at negative 1, 0. So I plot that point, and having plotted that point, it's now the same old x squared graph that I've been doing for a long time. So over 1 and up 1, over 2 and up 4, over 3 and up 9, and then go ahead and draw in your curve. So the basic idea here is that anytime you're given a quadratic equation in standard form and you are asked to graph it, you will find the vertex by using x equals negative b over 2a. And then once you've found that x value, plug it back into the original equation to find out what y is, plot that point, and then graph x squared as usual.